Number of threads you can create in a Linux process before it becomes a burden depends on several factors, including system resources, the specific kernel settings, and what the threads are doing. Here is a detailed look into these aspects. System resources. The primary limitation on the number of threads in a Linux process comes from the system's memory resources. Each thread requires its own stack space, and so it requires around 2 MB to 10 MB per thread. Therefore, the total memory available and the stack size of each thread determines how many threads can be created. For example, with 8 GB of RAM and a thread stack size of 8 MB, typically you can create around 1000 threads. However, this doesn't account for the memory used by the program itself and other system needs. The number two constraint is the kernel parameters. Linux has specific kernel parameters that directly affect threading, like the max threads derived from the total available memory and the kernel's thread size. You can find the maximum number of threads per process by executing this command. And another parameter, kernel parameter that determines is PID max, the number of process identifiers you can have in a Linux system. Since each thread in Linux is like a lightweight process with its own PID, this limits the number of threads as well. Also, there are some practical limits. The number three constraint. The ideal number of threads in process should not exceed the number of cores. If the threads are CPU bound, having more threads than cores leads to context switching, which can degrade performance. However, like if the threads are IO bound, performing mostly waiting tasks, you can have more threads per core. Also, there are some fourth constraint is the performance considerations. Creating extremely high number of threads can lead to the following issues: increased context switching. More thread means more context switching, which can significantly slow down the system performance. Resource contention. Threads might compete for CPU, memory, and other system resources, reducing the effectiveness of multi-threading. Then the scheduling overhead, the kernel scheduler has to manage all these threads, adding to overhead. So more thread means more scheduling and more overhead. Lock contention in multi-threaded applications. More threads may increase lock contention if they frequently need to interact with shared data. The fifth constraint is like monitoring and managing threads. We can monitor and manage thread usage and system performance using tools like HTOP, TOP, and PS, which can help understand the practical impact of your threads on the system. And in conclusion, like there isn't one size that fits all to the maximum number of threads that should be created in Linux process. It largely depends on the application's nature and system's configuration. as a general best practice, keeps the number of threads at a manageable level, ideally close to the number of processor cores if the workload is CPU bound. For IO bound operations, uh, thread count can be higher, but always monitor performance and adjust based on the actual system behavior and performance measurements. That's it. Thanks for watching. Please like and subscribe. Let me know if you have any comments or questions or suggestions. Thanks a lot. Bye.